The first example, the integral from 2 to 2 is just equal to 0 from the basic rule of the definite integral. For the next example, taking out the coefficient of 3 in front of the integral of f of x dx and separating it from the integral from 1 to 2 of 1 dx. The integral from 1 to 2 of f of x dx is just negative 3. To look at the integral from 1 to 2 of 1, we're looking at a function at y equals 1, and the integral from 1 to 2, so we're looking at a rectangle. That rectangle has a base of 1 and a height of 1. So we got 3 times negative 3, which is negative 9, plus the 1, so the integral is negative 8. For part C, we're looking at the integral from 2 to 5 of f of x dx. So we need the integral from 1 to 2 of f of x dx, plus the integral from 2 to 5 of f of x dx, and that equals the integral from 1 to 5 of f of x dx. So the integral from 1 to 2 was negative 3. Integral from 2 to 5 of f of x dx we don't know. And the integral from 1 to 5 of f of x dx is just given as 5. So the integral from 2 to 5 of f of x dx is equal to 8. So the function is continuous, and we're looking at the fact that f of x is going to sit somewhere between 2 and 4. So drawing our function somewhere between 2 and 4, and we're looking on the interval from 1 to 3. So this is an estimate of a sketch of what that would look like. So calculating the integral from 1 to 3 of f of x dx would have to be less than or equal to the base of units 2 and the height of a unit of 2 as well. So the base would just be 3 take away 1, and the height, which would also be a value of the 4 take away the 2. So at most, the integral from 1 to 3, or that area, is going to be as large as the number 4. So the greatest possible value then would be 4. So using the semicircle, we're looking at the function from 0 to x of f of t dt. We need to figure out g of negative 2, so we're placing negative 2 in for x, looking at the integral from 0 to negative 2 of f of t dt. So that's saying the opposite of the integral from negative 2 to 0 of f of t dt, if we want to go forward in our graph. So the integral from negative 2 to 0 makes up a quarter of a circle, which is 1/4 pi r squared, which in the drawing, the radius is equal to 2. So that just makes pi. Since we're going backwards, that's going to be a negative pi. Looking at the integral from negative 1 to 1 of h of r dr, plus the integral from 1 to 3 of h of r dr, that's equal to the integral from negative 1 to 3 of h of r dr. Negative 1 to 1 is just 0. Integral from 1 to 3 of h of r dr is what we're looking for, and negative 1 to 3 is 7. So the integral from 1 to 3 of h of r dr is also equal to 7. Part B, we're looking for the negative integral from 3 to 1 of h of r dr, which is the opposite of the integral from 1 to 3 of h of r dr. And 1 to 3 was 7. So we're getting the value of 7. So in our multiple choice, we're looking at a function that's continuous, and we know that the order of the terms, or order of the x values, are going to be a, c, and b. We're going to have some sort of function in which we're looking at the integral from a to c then, plus the integral from c to b is equal to the integral from a to b. By solving for the integral from c to b, that's equal to the integral from a to b of f of x dx minus the integral from a to c of f of x dx. And then that matches letter choice D.